no. Okay, so previously خلصنا salts. When it comes to acidic and basic salt, we said that we always look at the active ingredient that we have, or the active component. For example, إذا بنرجع شوي لورا نتذكر إنه if you have a salt like CH3CONA, the first thing that you do is dissociate the salt. انتبهوا في فرق between a salt وفي فرق between an acid وفي فرق between a base. Okay, a salt is basically an ionic compound that dissolves in H2O. هلا قديش it dissolves, it depends on solubility اللي حندرسها بعدين. So the first step when you have a salt is dissolve it. Usually خلينا نقول 99.99% of salts اللي حناخدهم اللي فيهم صوديوم حيكونوا salts that dissolve completely in water. Okay, so they are strong electrolytes, they have complete dissociation. Break down the salts into the respective ions. What does that mean? Break down the salt into the anion and the cation. هون بكل بساطة واضح. The cation is Na+, so we break it down into Na+, and then we break it down into CH3CO-. You already know from your experience, from previous خليني أقول explanations, إنه Na+ is not an active component. It is, in fact, a spectator. As long as it is a spectator, it will not خليني أقول affect anything in the solution. بالتحديد, it will not change the pH of the solution. It has no effect on the pH of the solution. So simply مثل ما أنا هون عملت cancel Na+. Now you have the anion, which is the acetate. Acetate إذا بتطلع فيها أنا بالgiven in the question, for example, تخيلوا أنكم عم تحلوا exercise بالgiven, they will tell you that the pKa of CH3COOH, CH3COO- is equal to 4.75. افترضوا اجاكم ion أو salt انتم ما شايفينه قبل. Okay, you break it down into the anions and the cations to know if one of the components اللي انتم مش مرقين عليكم قبل, so you don't know if they are spectators or not, بس بعدين بالexperience you will know. When you break it down, look at the given. If in your given you have a pKa of a species, هيدي ال pKa, it means that this species can behave as an acid or a base depending على الكابل اللي عندي إياه أنا. So I have the anionic couple CH3CO- which can accept a proton, so this is the base. ساعتها باخد البase and then I react it with H2O to give the acid and HO-. Now you study the case of a weak base. بكل بساطة. How do you find the pH of a solution that contains a weak base? You say that pH is equal to 7 plus half pKa plus half log C if it is greater or equal than pKa plus 1, or if the original concentration of the base is greater than 100 kb. It's very simple. The same can be applied when you have an acidic salt. مثل ما قلنا مرة الماضي. You break down the salt. If you don't know the species that are present, you look at the pKa. If the pKa is given for one of them or both, you know that one of them or both, they act as acids and bases, and then you calculate the pH according to the acid or the base. But we do have a condition. Yes, there is a screen. We do have a condition where instead of having an acid or a base, you will have an acid and a base, both of them. So you come into a situation when you have to study the competition between the acid and the base, يعني the contribution of the acid towards pH and the contribution of the base. هي فعليا غلط إذا أنا بدي أقول the contribution towards pH. No, the contribution towards H3O plus and HO- اللي هن حيأثروا على pH. Let's take an example of an acidic and basic salts. Acidic and basic salts. I just need to change the color a little. So, acidic and basic salts are basically salts that contain both acids and bases as active constituents. For example, هاخد أنا the simplest salt that we can find, which is CH3, COO, NH4. It's important to know the source of certain salts. Okay, remember that we said that acidic salts should source اللي قلنا يعني how can you make an acidic salt? It's basically strong acid plus weak base will give you a salt اللي هو acidic salt. Okay, for the basic salts, strong base plus weak acid will give you a basic salt. For acidic and basic salts, you have a weak base and a weak acid. At the end, it will give you a salt. This salt has a concentration of C. The first thing that you do, it's a salt, so it's a solid. On its own, it's a solid. First thing that you do, break down the salt. افترضوا أنا ما عندي مطرح to break it down, so let's break it down هون. First step, break down the salt. CH3, COO, and H4. هون دايما في السؤال إنه does the salt break down completely؟ يعني does it dissociate completely in water? So far we will assume yes until you learn the concept of KSP and the concept of solubility of salts. So we will assume that this salt, انتبهوا هيدا منه acid منه base. So far I'm working with a salt مع إنه it contains an acid and a base. بس لتعرفوا أيمتى I put this arrow and أيمتى I put a double-sided arrow. When you break down the salt, you break it down into the anion and the cation. So that's CH3 COO minus plus NH4 plus. Now you look at what you have. You look at the anion and at the cation. Suppose you don't know them, look at the given that you have. From the anion and the cation, I know إنه هذا الanion it behaves as a base. CH3COO minus actually reaction 2 can behave as a base. وكلنا صرنا نعرف reaction of the base weak base بالتحديد double sided arrow into CH3COOH plus HO minus. Basic. This reaction renders the pH of the solution basic and it produces HO minus. You also have a cation. This cation in reaction 3 plus H2O will yield NH3 اللي هو الconjugate أكيد plus H3O plus. Again, it will render the solution acidic. So you have two sources home. One source that yields HO minus, another source that yields H3O plus. It means that you have something that is contributing towards an acidic pH and you have something that is contributing towards a basic pH. What we do in this case is study each on its own. هلا أكيد we will also introduce validity that will help you find the answer very quickly. In the exercises بنوسع هيدي الانالوجي أو بنوسع this explanation so that you know how can both of them contribute. So in general we can say that if the Ka of your acidic component is equal هكتبها هون حتى. If the Ka of the acidic component is equal to Kb of the basic component, مين هو الأcidic component NH4 plus. This is the active acid is equal to Kb of the basic component. شو قصدي بالbasic component? Whatever is rendering the pH basic. If Ka is equal to Kb, in this case, I can say that the strength of the acid is equal to the strength of the base. مش بس هيك. And the concentration of the acid is equal to the concentration of the base. Why did I say that they have the same concentration? Because they originate from the same salt. So if you start with the concentration C of the salt, هيدي C when it dissolves completely بدها تختفي وحيبين عندكم C for this one and C for this one. They have the same concentration. So this is also an important rule. Okay, so Ka of the acid is equal to Kb of the base. Both of them have the same concentration. ودايما they will have the same concentration when they originate from the same salt. Then I can say that the pH is actually neutral لأنه they balance each other out. If Ka is greater than Kb, and you're saying the strength of the acid is greater than the strength of the base, but they still have the same concentration, then you have an acidic solution. Why is it acidic solution? بكل بساطة لما بقول إنه strength of the acid is greater than the strength of the base, it means that the acid dissociates more than the base. So the value of H3O plus will be more. The value of H3O plus released, this one, will trump or exceed HO minus, so the solution will be acidic. Now, what is the pH of this solution? This is when we start to calculate. If Kb is greater than Ka, Kb greater than Ka, then you're saying that the basicity of the base is stronger than the acidity of the acid. It means that this base will dissociate more than the acid, so the value of HO minus released will be greater than the value of H3O plus released. So this will give you a basic solution. All you have to do is compare the Ka and the Kb. Now calculate. This is something important. So calculate the pH of such a solution. We can calculate it with only one line, and I will show you how to get to that line. To calculate, we have to establish validity again. So consider the sodium acetate اللي كنا عم نشتغل فيه, and you have the acid, not the acid, it's actually the base, بس عم بحكي أنا عن أول couple. The first couple has a pKa of 4.7. The second couple has a pKa of 9.2. Now انتبهوا على something. بهذا السولت, the base is CH3COO minus that has a pKa of 4.7. The acid, خليني اكتب هون, mean is behaving as an acid, NH4 plus, and NH4 plus has a pKa of 9.2. How do you calculate the pKb? Do you remember? 14 minus 9.2. Okay, so that's 4.8. So you can find the pKa and the pKb of every species that you have, but you have to remember something. You need to differentiate مين الacid ومين البase, مين the active acid and مين the active base. And you already know that this salt, هلا أنا قبل شوي كتبتها, it breaks down into the anion and the cation. You start with the same question. What if they don't have the same C? This will be a completely different question that we will answer during the exercises. Okay, we will have to, in validity for acidic and basic salts, we start from the same concentration. If you don't have the same concentration, you cannot use هيدي الفاليديتي اللي هلا حنعطيها. وعم سبق أنا شوي. So ركزوا على الفاليديتي, okay? You start with the same question. What are the species present? واضح. What are the species present? في عندي CH3COO minus, NH4 plus. أكيد ما تنسوا الconjugates اللي إلهم اللي هي H3COH and NH3. كمان ما تنسوا إنه you have H3O plus, HO minus and H2O. The only thing that you do not add is this one, because it is a solid that has dissociated completely. So that's why I can say that its concentration is now 0. وهذا concentration has been transferred into the acid and the base. Again, you start with the reactions. first reaction هي الauto-ionization of H2O، كده صرنا بنعرفها. السكند reaction هي اللي كتبتها أنا قبل شوي. هي فعليا أول reaction is this one, but this no longer participates لأنه خلص it's one arrow. أوكي. السكند one هي مثل ما كتبتها أنا قبل شوي البيس. The third one is for the acid. طيب what are the relationships of this solution؟ من أول وحدة ال KW، من تاني وحدة you have ال Ka of CH3CO-، ومن تالت وحدة you have ال Ka. Remember it's easier to work with Ka than to work with Kb. So هسميهم أنا Ka1 هيدا couple 1، Ka2 and this is couple 2. You also have electroneutrality and mass conservation. خلينا نشتغل كل وحدة بوحدة. ال KW very easy. You all know that H3O plus times HO minus is equal 10 to the negative 14. ال electroneutrality كمان صرنا نعرفها. You have the species هون، هيهون ال species عندكم. Okay. Simply cation وكلهم عندهم plus 1. Remember if you have plus 2 plus 3 أو minus 2 minus 3 you have to multiply بهيدي 2 و 3 absolute value. What else do I have? Neutral, so no. And then we have CH3COO minus and HO minus. So basically the blue equal to the yellow. This is the electroneutrality اللي كاتبينها هون. And now it's the mass conservation. لوسع شوي mass conservation. Remember that we started with، خليني أقول أنا CH3COONH4 plus. This broke down completely into CH3COO minus plus NH4 plus. هون عم بسع أنا الماس conservation اللي هي third equation. Okay, you start initially with C, nothing. Then at the end of the reaction, because this is a complete reaction, you get 0, C, C. So basically, the concentration of CH3COO minus must equal the concentration of NH4 plus. However, this is incomplete. Why is it incomplete؟ لأنه هون أنتم عم تفترضوا إنه مشيتوا بأول equation اللي هي the dissociation of the salt ووقفتوا. That's not true. So after the dissociation of the salt, what is the second equation that happens؟ اللي نحن كتبناها هون. هنرجع لهون. Second equation that happens is that the acid itself or the base itself will lose the value of X from the anion and will gain it home. The same thing. Will lose the value of X, gain it home. خلينا نشتغل بالتو. أنا بدي حافظ على C equal to C. لحافظ على C equal to C اللي هي الأوريجينال اللي كتبناها قبل شوي. You have to start من C. Initially C كانت CH3COO minus والsecond C كانت ال NH4 plus. هيدي initially بالICE table. At the equilibrium of the ICE table شو صار عندكم؟ شو صارت الC؟ الC هي basically now C minus X plus X. صح؟ C minus X plus X. Mean is C minus X. C minus X is concentration of CH3COO minus, لأنه this is the value that lost an X, and CH3COOH, this is the value that gained an X. In this way, you preserve إنه it's still C، لأنه C minus X plus X هي C. Conservation of mass is equal. نفس الشيء لل NH4 plus. NH4 plus after the initial خليني أقول stage، يعني لما توصلوا على equilibrium it loses an X، بيبقى عندكم ال NH4 plus remaining، وهيدي ال X that it lost it is gained by NH3. And this is the conservation of mass that you see here. It starts as C equal to C. after the first reaction, but you have 2 3. 2 heat dissociation of CH3CO minus, the 3 heat dissociation of NH4 plus. So you have a value that is lost. هيدي value that is lost is gained by the conjugate. So this is why أنا بكتبهم هيك. The overall هو C. The fourth is Ka. كلنا بنعرف شو هي ال Ka. اتفقنا إنه couple 1 هو الأسيتيت، couple 2 هو الأمونيا. Now, for a solution that is sufficiently concentrated, remember this property that we took. For a solution that is sufficiently concentrated, we can neglect the concentrations of HA3O plus, HO minus with respect to the first or original concentration of the salt. We can neglect it. So basically, we can neglect the HA3O plus, we can neglect HO minus with respect to the concentration of the components اللي جايين من الصوت. إذا بترجع لهون شوي, you can neglect this H3O plus with respect to NH4 plus لأنه you're working under the assumption that it is a very weak acid. It will not dissociate properly in your solution. You can neglect the HO minus, and also we neglected the autoionization. Don't forget. When you neglect NIT2, بدل عندكم ال NH4 plus is equal to CH3CO minus. Original equation. I'm neglecting their dissociation. NIT3, since من هون بين عندي إنه ال NH4 plus is equal to CH3CO minus, then CH3COOH will NH3 can be neglected also with respect to the original concentrations. يبقى عندي هيدول. بما إنه حددت أنا إنه هيدول الاثنين equal, I can say إنه this will cancel this. Because the value of the acid produced is the same as that of the base. Now what you can do is simply take Ka1, Ka2 and establish a relationship. Okay? Take Ka1 and Ka2. So Ka1 times Ka2 is equal to times. When الفكرة, pay attention to what you have to cancel. So from these two equations, I can cancel the CH3COO minus with NH4 plus هي هون. I can also cancel CH3COOH with NH3, and you can only cancel them because أول شيء they originate from the same salt. Okay, so they basically have the same concentration, which is why I can cancel them. And that equilibrium, you neglected the H3O plus with respect to NH4 plus and the HO minus with respect to CH3CO minus. You're also neglecting their dissociations. This is why you can cancel them. What you get is H3O plus squared. So Ka1 times the Ka2 is equal to H3O plus squared. Now insert negative log على هيدي H3O plus. What do you get? Negative log H3O plus السكوير دغري حنزلها لهون. اتفقنا؟ خلينا نحط الماينس هون وهيدي السكوير is equal to negative log Ka1 negative log Ka2. Yep. Negative log H3O plus, it's pH. خدوا ال 2 لتاني جهة to make it half. Negative log Ka1 هي pKa1 plus negative log Ka2 هي pKa2. Very simply, when you have a salt that has both components, اللي هن الأسيد والبيس، دغري بنكتب أكيد في conditions. أول condition إنه ال Ka الأولى بدها تكون approximately equal لل Kb للتانية. اوكي. اكيد السي equal للسي لانه they originate من the first. خليني اقول they originate from the same source. بنوسعهم هيدول اكتر بالاكسرسايز يلي ما بيكون عن السولت. You simply say in this case pH is equal to pKa1 plus pKa2. Whenever you have a salt أعطاكم acid and the base of خليني أقول equal concentrations and equal Ka and Kb, pH equals half pKa1 plus pKa2. Moreover, هيدي condition you can use it for all amphoteric substances. You remember what amphoteric is? Amphoteric are substances that can act as a base and an acid. Okay? What is pKb هون؟ What is pKb هون؟ في range للKa والKb حنتعلمها بالاكسرسايز أكتر. It's okay. في range بس نساوي الكالكوليشن you will see the range of Ka and Kb. Okay. Remember that the same equation can be used if you have an amphoteric substance like Ha minus. The same one. بس لحتى تتأكدوا من الكونديشنز خلينا ناخد ال PKB. ال PKB هون what is it? It's 14 minus 4.7. قد ايه 14 minus 4.7? It's approximately what? 9.3. طلع أنا عم بشتغل بالبيس which has a PKB of 9.3 and the acid which has a pKa of 9.2. Conditions that you need to use this equation is أول شيء the pKa of the acid must be approximately equal to the pKb of the base. في range. تاني condition the C of the acid must be equal to the C of the base. Then you can use the pH is equal to half pKa plus pKb. These conditions are always satisfied, well, most of the time are satisfied in salts, but they are always satisfied in amphoterics like Ha minus. So whenever you have a salt انتبهوا إذا هذا السولت ال pKa للبيس is equal لل pKb للبيس is equal to pKa للacid. Because it's a salt, they have the same concentration. This is how you find the pH. If you have an amphoteric or an ampholyte in your solution, don't wait, don't do anything. دغري pH equals half pKa plus half pKb. Okay? Now, another way that you can find this equation, طريقة تانية لنلاقي هالequation, even though I do not like this way, is to use Henderson-Hasselbalch. بس هون بدنا ننتبه على something very important. Start with the first couple. اكتبوا الهندرسون-هاسلباك لإله. هذا أول couple. كلنا بنعرف كيف نكتب الهندرسون-هاسلباك now. It's pKa plus log البيس على acid. بما إنه it's couple 1, so it's pKa1. Second couple, that's pKa2 plus log البيس divided by the acid. Because the pH of the solution does not change. أنا بsolution هذا solution has a certain pH. Okay? ما بعرف كيف وصلت لهالpH, بس you cannot say that one solution has two pHs. No. This solution has one pH. It's this one and this one. So in fact هيدا كلياته is equal to this pH, this is equal to this pH. عنده نفس pH. In this case, and only in this case, I can add the two. pHs are not additive. برجع بعيد. pHs are not additive. أنا إذا عندي acid وإذا عندي base غلط إنكم تجيبوا ال pH من الأسيد وتجيبوا ال pH من البيس وترجعوا تجيبوا الأفريج بيناتهم. That's not correct. The pH is not a mathematical property. It cannot be added. This is why I don't like this example. It cannot be added unless the pH is the same, unless you're adding the same pH. Okay, يعني 5 and 5. If you add it, you get 2 pH is equal to pKa1 plus pKa2 plus log base over acid. And if you remember, the relationships that I did last time, we said that the concentration of this one is equal to this one, and the concentration of this is equal to this. You get pH equals half pKa1 plus half pKa2. Don't think too much about this reasoning. Okay? Remember, pHs are not additive. You can never add pHs. This is not a property that you can add. Okay. Questions? Yes. Ala, yes, okay. Well, what you said is true. We have to assume that when we say that pK is equal to pKb, this is why we assume that you can neglect the HA3O plus with HO minus with respect to the original concentration because the dissociation is very low and it is equal. مش بس very low, it is equal dissociation. Okay, so let's start with a new recording.